Okay, so I'm just checking the audio. That's pretty loud. All right, so let me get out of there. Hopefully this doesn't ruin everything. Yeah. And okay. Yes. Firefox. Let's go new. All right, so just doing the same old thing that I always do. I need to figure out something to do with this content once it's like made. Let's see. For each of these functions, plot and indicate its domain. Okay. Working on your problems in my live stream. Let me get that link. Copy. Paste. Ah, come on. Copy, paste, insert. Starting at 2 minutes. All right, I probably should have even looked at this problem to make sure. Oh, for each of these functions, plot and indicate its domain, its image, and its intersections of the graphs with the coordinate axes. Okay. I'm gonna screen grab this instructions too. And find the set of values of x for which h of x is greater than 2. Okay, so let me bring this problem in. Boom. We're gonna go there. And I'm gonna bring in function 2, which I think I took a, no, I did not take a screenshot of the function. Or whatever, I'll just copy the function. Okay, so just like following that link, I got h to be h of x equals 4 minus the absolute value of 2 minus 2/3 x. All right. So there is that. And yeah, so this is what I'm working on. Boom. All right, so we got everything we need here. Okay. So for each of these functions, plot and indicate its domain. So plot its domain. To me, that sounds like they want this. They want the graph. So let me. I'm gonna make the graph and then I'm gonna plot the domain if that's like a separate thing. I don't super understand what they. How do I do this? I forgot how to. Oops. So here, I'll make a graph here. So we got some axes, and then let's see. Let's think of what this graph is. So to figure out what this graph is, there's a bunch of ways you can think of this, but you know, let's plot h of 0. This is the x-intercept, and so we're going to get 4 minus absolute value of 2 minus 2/3 times 0. Which is equal to, so this becomes 0. 2 minus 0 is 2. Absolute value of 2 is 2, so that's just 4 minus 2, which is 2. So we know that, you know, let's call this y equals 2. There's going to be a point on the graph right there. Okay, so that's just like some information you can use to make sure that you're doing everything correctly. Another thing that we can do is look for the x-intercepts. So we could say like 4, oops, let's go 4 minus absolute value of 2 minus 2/3 x equals 0. Okay, that's fine. So I'll add this like absolute value mess to both sides, and what I get is absolute value of 2 minus 2 over 3x equals 4. So what does that mean, right? That splits into two things. Either the stuff inside there is 4, or the stuff inside there is negative 4. That's how you interpret the absolute value. It's like whatever's inside here is the magnitude of it, the absolute value is 4, but it could either be positive or negative. So let's just write those two equations. That's going to give us two solutions to this. 2/3 x equals 4, or 2 minus 2/3 x equals negative 4. Okay, either way. So I'll subtract 2 from both sides and multiply both sides by negative 3/2. So we get this canceling here, and so x equals negative 3. Similarly, we can do the same procedure here. So minus 2 minus 2, we'll get negative 2/3 x equals negative 6. Multiply both sides by negative 3/2, negative 3/2, and then we're gonna get cancel, 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 cancel. X equals, so this is going to become positive. 2 cancels there, and we have 9. So x equals negative 3 or 9. So let's call this negative 3. This can be positive 3, positive 6. Okay, 9's way out here somewhere. So just, this is not to scale. Although that doesn't feel, oh yeah, okay, I'm with you. So the idea is that now you've got some like, let me just put this point on real quick. So you've got this point here, you've got this point here, and you know, you got to know that this is a line. Okay, so the first thing is like, this is the line that has you know what, let's put one other point on here, which is gonna be like whenever this mess equals 0. And I'll try to explain why I'm thinking that way. So let's do like 2 minus 2/3 x equals 0. I want to know when this thing equals 0. It's going to be when 2 minus 2/3 x equals 0. So when 2 equals 2/3 x, and then when x equals 3. Okay. And you can kind of see like this distance is 6. Oh wait, I did something dumb right here. That's 6. So this is 3, 6, and then 9's like way out here. 9. So we actually want this point to be right there. Okay. You can kind of see like this distance is 6, this distance is 6 between here, and in between those 2 points you have, it's going to be at y equals 4 there. So that point's also going to be on line. That's actually what I'm looking for with this equation here. I know that there's that on an absolute value function, there's the little point in the v. So that's what I'm looking for when I'm working on that. And if you take that x equals 3 and plug it in, you would get 4 minus, you know, the absolute value of all of that is, it goes to 0. That's what we just found out. So this is 4. So that's, no, 4. That's the point 0, or 3, 4, 3, 4, right? Which is this point here. So I know that's there. There's an easier way to do this, which I'll talk about in a second. But anyway, so now we've got this point, and we've got the, ooh, look at that. I did a pretty good job with that. And then it looks like this. So this is an absolute value function. If you've seen one absolute value function, you get the idea. It's just transformations on that. So this is our plot here. But let's talk about how did I figure that out. So the absolute value function, the main one that all the other ones are built off, is like the line y equals x over here. So this is like y equals x. That has slope 1. It goes through the origin. This has slope -1. It goes to the origin. This is the absolute value of x. Whatever x is, you take the absolute value of that and you get y. That's why like negative 3 should map onto positive 3 over here, right? Positive 3 should map onto positive 3 up here. Okay, so you get that even symmetry there. Now we just need to do transformations on this, and this is how most people think of it. So let's say g of x is equal to the absolute value of x. That's this function. Okay, how do we turn it into this? Well, one thing we can do is we can do g, instead of g of x, we can do g of 2 minus 2/3 x, right? Let me write that in a slightly different way. This is going to be negative 2/3 x, and then, oops, sorry, negative 2/3 x plus, what would it be? So we need minus, so 2/3 times what equals 2? It's going to be 2/3 times k equals 2, so 3. 3. Okay. Now, if you FOIL this back in, you'll see that it equals this. That's what I'm looking for. So this is the absolute value of 2 minus 2/3 x. Well, let me write it the way I have it there. Negative 2/3 times x minus 3. So why did I do that? What reason did I do that? This, understanding what transformation happens inside those parentheses, which we say like inside the argument of the function, helps me to think through how to shift this graph around so I get the graph that I'm looking for. What does this thing do? When you multiply inside the argument of the function, that will either stretch or shrink in the horizontal direction, your graph. And if you multiply by a negative, it will flip it over the y-axis. So first we're going to shift our graph to, let's do the shrink first. So we need to shrink it this way, or no, I'm sorry, stretch it, because it's inside, it's between the absolute value of negative 2/3 between 0 and 1. So I need to stretch it by 3/2, if that makes sense. So everything gets like pushed out this way, okay? Then we'll shift it to the right 3 because we subtract. Like everything's backwards from how you would expect. So this point gets moved over to here, and then what is this? This is like 2, 2, so that would go to 3, 2, and then that gets shifted over as well, so that ends up like here. Okay, so we've got these points on now. Then all of these points are going to get modified by this and this, so let's do that too. So now we're going to multiply g of negative 2/3 x minus 3 by negative 1 on both sides. And it gets that. What does that do? Well, that affects outside the function. When you multiply by a negative, flips it over the y-axis. So this takes all of these points and flips them down like this. So we shifted it and stretched it in the horizontal direction. Now we flipped it in the vertical direction. Now we're down here. And then we've got one more thing, which is to add 4. So we'll add 4 to both sides. Okay. This is h of x. That's what we started with. So I just built h of x out of this function. And don't go through all of that unless you like want to. It's pretty easy for me to do that now because I've been doing this for a while. But you know, if you don't want to do that, don't do that. All you really need to do is choose a couple values for x. You know you want this to equal 0. You want that x value where that equals 0 because that's going to be the cusp. And anyway, this thing, the final graph shifts up here after you do all those transformations. Everything shifts up 4, so you end up with, you know, whatever we had before. Sorry, I'm not good at sketching, but anyway, something like that. The easy way to do this is plug in values for x. Okay, you want to make sure you got that, whatever's inside the absolute value bar, equal to x or equal to 0. Make sure you have that x value plotted. That's going to be that cusp. and then you just need 2 more points. It's 2 lines. So absolute value functions are pretty easy. Now the same sort of idea is going to be there for how I figure out the rest of this question, and that's why I wanted to go through that with the graph, even though it's probably not very easy to think through that, and I did a terrible job explaining it. Okay, so now indicate its domain. So looking at that function, h of x equals 4 minus absolute value of 2 minus 2/3 x. Looking at this function, is there any x value that doesn't go into this function? That's what we're asking ourselves. In order to describe what the domain is, sometimes it's a lot easier to think through what is it not? What x values are not allowed to go in there? Now, if we think of that parent function, the absolute value of x, we're good. Like everything can go in here as far as x goes. Okay? Any x value can go in there. This is defined for all real numbers. Now, multiplying by negative 2/3 isn't going to change anything. Adding 2 is not going to change anything. Multiplying by negative 1 is not going to change anything. Adding 4 is not going to change anything. All of those real numbers are still in there. That's our domain. So the domain of this thing is x. You can say like x is all real numbers. You can say x is from negative infinity to positive infinity, whatever you want to do with that. They say plot and indicate its domain. So I don't know if they meant plot the domain. I think that's kind of a weird thing to do. I think they actually meant plot the function. If they wanted you to plot the domain, you'd go like, you know, this. I don't know. I don't know why you would plot the domain like that. So probably they want this type of answer here. What's the domain? And then plot the function. Its image and the intersection of graphs with the plot and indicate. Okay, so the image is like what the domain gets mapped onto, the range, I'm assuming is what they're meaning here. So the range is like h of x is, we have to think of what our highest number was. The highest number is 4. The lowest of this can be is 0, and then you subtract whatever that is. So if this is bigger than 0, it means you're subtracting a positive number, which means it's going to decrease from 4. And we saw that on our final graph. It was like we had this point at 4, I think this was 3, and then it looked like this, right? The y values start at 4 and then go down. So we just have to describe that in interval notation. So h of x is on the interval from negative infinity to 4, and we include 4. And in that process of graphing it, we actually found the intercepts, the intersections of the graph with the coordinate axes. So we found when x equals 0, we found h of 0 equals, what did we get? We found negative 3 or 9. So these are the, oh no, I'm lying. When x equals 0, we have 2. So this is the y-intercept. Y-intercept is 0, 2. That's what we found at the beginning. Then the x-intercepts, we found out when y was 0, we had negative 3 or 9. So negative 3, 0, and negative 3, 9. Yeah. It was kind of scattered, my first one, just getting warmed up. Hopefully that helped. If you come in here, I don't think you're in this yet. Oh, maybe you were. We got 3 playbacks. Okay. Well, you know, say something in the chat if that was terrible. I know it wasn't my best work, but I want to be able to help you, so definitely let me know. Okay, I'm going to find another one. Vector value functions. I'm trying to look for stuff that's like, oh, maybe am I sorted by new? Yeah, I'm sorted by new. Trying to look for stuff that's unsolved, because, you know, what fun is it to solve something that's already solved? Find the function r that satisfies the following conditions. Only 3 attempts on this problem. I don't know if this is, I don't super know how to use Imgur. I don't even know how to say that. So I'm not sure what this is, but let's work on it. So we're gonna go boom. Well, maybe I should even tell this person I'm working on their problem before I start going. And I could go there. Working on your problem in the live stream. I should probably, I do this every time to myself. I like pull this problem up and I don't even know if I can solve it, so I'm gonna, I guess I'm being honest when I say I work on it. I'm like working on it, not that I'll be able to solve it, but I don't know. Somehow I managed to get an A in Calc 3. Or no. I thought I was crushing Calc 3, but I ended up with a B in it, and I got an A in differential equations, even though I had no idea what I was doing in there. All right, word. So let them know. Did we? Yeah, we did. And okay, so find the function r that satisfies the following conditions. Okay, so they give you r prime, and they want us to find r. Then we're given this point of data. R of 1 is 4, 5, negative 5. All right. So basically, the idea is that we want to integrate this function. We want to find the integral of r prime of t dt, which this is a vector valued function. So essentially what we're going to do is just integrate each of those. That's the idea. So let me just back this all up. So we're going to do the integral of 5t to the 4th dt is going to be equal to t to the 5th. Well, we'll say 5t to the 5th over 5, right? That's the power rule. These will cancel, so it'll just be t to the 5th. Yeah, let me do a better job here. So this is 5t to the 4 plus 1 over 4 plus 1 plus c, which everyone forgets. We need that here, and you'll see why in a moment. Then we've got 5t to the 5th over 5, and these cancel, and so we get t to the 5th. Let me put my plus c equals t to the 5th plus c. Okay, so let's hold on to that for a second. This is our like x of t. Say x of t. All right, that's this thing right there. Or rather, I should say that's the for r. Then we've got y of t is going to be the integral of 2t. So 2t dt. And this is going to be equal to 2t to the 1 plus 1 over 1 plus 1. This is the power rule plus c. And that's 2t squared over 2. Cancellation. And then we got t squared plus c. So let's hold on to that for a second. And then z of t. We're going to integrate that to get it, the 3t squared. So this is going to go to, you know what, I should probably know whether or not I'm, okay, we're good. So we've got integral of 3t squared dt. This goes to 3t to the 2 plus 1 over 2 plus 1 plus c. Same process, all power rule. 3t cubed over 3 plus c equals t cubed plus c. So now we've got these three functions right here. And you know what? I'm going to put like c1, c2, and c3. These are not all the same constant. That's really important to know. And I need to find those numbers. How do I do that? Well, I know when I plug in 1 for t, I get 4 for x, 5 for y, and negative 5 for z. So I just fit those functions. Okay, so from here, I'm going to do x of 1 is equal to 1 to the 5th plus c, 1, which is equal to 4. Okay, so 1 to the 5th is 1. Subtract 1 from both sides, c1 equals 3. So that is 3, which makes this t to the 5th plus 3. So that's correct. Then we're going to do the same thing here. We're going to do y of 1. So I plug in 1 and I get 5. That's what I should expect here. So that's equal to 1 squared plus c2, which we know equals 5. So 1 squared is 1, and subtract 1 from both sides, c2 equals 4. So this is 4, and we plug that into here. This is t squared plus 4. All right, last but not least, we got to plug in 1 to find z, which gives us -5. So I'm going to use this function. So 1 cubed plus c3 equals -5. 1 cubed is 1. And subtract 1 from both sides, c3 equals -6. So then this one is t cubed minus 6. T cubed minus 6. Yeah. Is there anything? Well, actually, this poster had a bunch of other problems underneath, and I don't know if these are from the same person. Like, I don't know how Imgur works. If this is an album or if this is like related photos that just get generated. I'm just gonna answer it. Whatever. Hopefully this is helpful. Well, I'm going to try to answer it. Okay, determine whether the following curve uses length as a parameter. Uses arc length as a... Oh, interesting. Determine whether the following curve uses arc length as a parameter. If not, find a description that uses arc length as a parameter. I don't super understand what they're saying here. Select the correct choice below, and if necessary, fill in the answer boxes to complete your choice. As a parameter, a description for that use arc length as a parameter is R of S. Let me look up real quick. Vector value function arc length. So, friggin' Paul's math notes. Oh my gosh, this website is so good. Whoever Paul is, somebody needs to send them in $1 million. Okay, so if we have this vector valued function, we actually already know how to do this. Recall that we're explaining it in parametric form. Okay. Oh, right. Okay. So then, two-dimensional parametric, the arc length is given by Pythagoras. Okay. Yeah, Pythagoras again. And okay. So determine whether the following curve uses arc length as a parameter. Oh, interesting. Oh, that's freaking cool. This establishes a relationship between S and T. Knowing this relationship explicitly, we can. Okay, so I just found a document of this. It says like S of T is equal to the integral from 0 to T of the magnitude of, so the arc length of the vector valued function R with this dummy variable u du. Okay, so the arc length thing, we can use Pythagoras to. Oh, okay, it was right in Paul's math notes the whole time. I didn't even see it. Yeah. So is this a definite integral? It just happens to be for that one. All right, so this is defined to be the integral from boom, boom. Notice the integrand is nothing but in the magnitude of the tangent vector. So the arc length is the integral of the magnitude of the tangent vector. And arc function. So select the correct. So determine whether the following curve uses arc length as a parameter. What would it look like? I don't think it does. So we now have to put it in the right form. So S of T equals. Okay, well, so this is the integral from 0 to T, or is it from 0? From 1 to boom, boom. S of T is from 0 to T. Yeah. Okay. From 0 to T of the magnitude of R, which is it R or is it R prime? Ah, yeah. Okay, this is R prime, so that's important. The magnitude of R prime, because that's what, are we given R prime? We're not given R prime, so we have to get R prime. So let me get R prime here. Equals 4t, 6t, and what is this going to be? This is going to be 12 root 3t. 12 root 3t. Okay, so that's R prime. And then so we need the magnitude of R prime. So this is going to be 4t squared plus 6t squared plus 12 root 3t squared, all square rooted. Better line. And then honestly, I should have kept the dummy variable in there. Like this should all be u. Just to keep the notation consistent. Sorry, I'm doing a bad job. Boom, boom, boom. Boom, boom, boom. U. Okay. All right, there we go. And I don't know if this is going to be super easy to integrate. Hopefully everything will shake out. So I'm going to square everything. So 16u squared plus 36u squared plus 144 times 3 is 300 plus 120 plus 12 is 432. 300 plus 120 plus 12 is, yeah. And, yeah, okay. Du. And they probably set it up so that's all going to work out nicely. This is going to be 16 plus 36 is 40, 52, 84, so 40, 52 plus 432 is 484, 484 u squared du. And let's see, is that a beautiful, look at that, divide that by 4, and that would give us 121. Oh, yeah. So this is 2 times 11, which is 22 u squared from 0 to t du. And then this is going to be, let's see, 22u cubed over 3, evaluated from 0 to t, which gives us 22 thirds t cubed. Okay, so that's the arc length function. All right, so now what do we do with that? Okay, so so it says determine whether the following curve uses arc length as a parameter. Doesn't look like it. If not, find a description that uses arc length as a parameter. So boom, we do that. We find this function s equals, okay, so basically what this is s of t, right? This is a chain of equality. So this is s of t. And we take that and it says taking this and plugging it into the original vector function, we can reparameterize this. Okay, so now we want to make t as a function of s, which, I think we can actually do here because it's t cubed. So basically I'm going to solve this for t. So t will equal 3 over 22 s to the 1/3. So just take the cube root of both sides. And then we plug that back into r. So we've got r of t of s, which is going to give us, it's like this is t of s here. So we're going to plug that in. So we're going to have 2 t squared, which is going to be 3 over 22 s to the 1/3, and that's all squared. Then we've got 3t squared, 3 over 22 s to the 1/3. Oh, look, I messed up. I was a little glib when I solved that. So 22 thirds t cubed equals s. So multiply both sides by 3 halves, or 3 over 22, we get t cubed equals 3 over 22s. Then we take the cube root of both sides, we get t equals the cube root of 3 over 22s. Cube root t equals, which gives us, I'm just going to write it as like exponential form because I like that better. Okay, so now we need to do like r of t of s. And this will be the like parameterized, so it's like 2t squared, which is 3 over 22 s to the 2/3. That's the square of this. Then we need to do 3t squared, so 3 over 22 s to the 2/3 again. Then we need to do 6 root 3 t squared, which is 3/22 s to the 2/3. And what will s be between? How do we do the... Oh, I guess you could okay, I'll tell you what the s is in a second. All right, can we clean this up? Let's make this... Honestly, I'll just leave it like that. I think that's clean enough. It's gross, but I'm not messing with all that. Okay, so then that's your answer for here. And okay, so we got to figure out what s is between. So we know t is between 1 and 4 from there, and then we know that t equals, 3/22 s to the 1/3. Okay, that's from here. So when t equals 0, or rather, let's use this version of it. Yeah, that'll be easier. So let's go from this one. So s is going to be equal to 22/3 t cubed. We'll evaluate that when t equals 1. T equals 1. This gives us 22/3. And then we'll do s equals 22/3 t cubed. And we'll do this when t equals 4, which is the other bound. And we get 22/3 times t to the, or 4 to the 3rd is 64. And that's like 128 times 11/3, which is 1280 plus 128/3, which gives us 3408, 1408. Somebody check me. 1408/3. I think that's right. 1314. Yeah, that looks good. Okay. And then so those numbers go in here and here. Yeah, I think that's right. Punch it in and let me see. Then what else? Okay, let's do the next one. This one. Ooh. I don't remember any of this stuff. Alright, so this is the next one. Import. Soft proofing. I don't even know what that means. What did I just do? Okay, boom, boom. Use the alternative curvature formula. All right. Alternative curvature formula. Let me see if I can find that formula. 3-dimensional space. Alternative curvature. Oh, I kind of remember this. Yeah. Okay, so this is like a cross product of two vectors to find the curvature of the parameterized. Okay, so yeah. Oh, okay. Is this... I think I know what this is. This isn't the way I know the formula. So I forget this little Greek symbol is called. I think that's Greek. It's the magnitude of the first derivative crossed with the second derivative, and then you divide that by the magnitude of the first derivative cubed. Okay, let's see what we can do. So the first derivative is going to be 7, or negative 7. Negative 7 sine of t. This is going to be root 7 cosine t. This is going to be negative 3 sine t. Okay, that's the first derivative. Then we need to cross that with the second derivative, which I'll just calculate based off that. So we're going to take the second derivative, so the derivative of this, and we're going to get negative 7 cosine of t. Then we're going to get negative root 7 sine of t. Then negative 3 cosine t. Okay. And we'll get the magnitude of that after we cross it. And then we already did the first derivative, so we can just copy this first vector down. Oh, sorry. Got my calculator falling everywhere. Which I don't even know where I had that out in the first place. Okay. So this is going to be magnitude of negative 7 sine of t, root 7 cosine of t, and negative 3 sine of t, magnitude cubed. And then, okay, so let's deal with this cross product here. So this is kind of like, I'm going to change the color so you know this is like an aside here. So I need to cross negative 7 sine of t. Then we've got root 7 cosine of t and negative 3 sine of t. Got negative 7 cosine of t. We've got negative root 7 sine of t. And negative 3 cosine of t. This is ij. I guess I should put the hats. Okay. And how do we do this? So it's like you cover up this one and you cross these two. So we get negative 3 root 7 cosine squared of t. Then you subtract these two, so it'd be minus 3 root 7 sine squared t. Okay, so that's the first one. Then negative, boom, we're going to cross these two, so this is positive 21 sine t cosine t, minus this, so minus 21, oh cool, sine t cosine t. Okay, that's the j, and then so now cover this and cross these. What do we get here? So we're gonna get 49 sine squared t plus 49 cosine squared t. And that's cool. This becomes, so if we factor out the negative 3 root 7, that's cosine squared plus sine squared, which is 1. So this becomes negative 3 root 7. This is a vector, by the way. Cross product gives us a vector. Then this plus this is 0. Negative 0 is 0. And then same thing here. We factor out the 49. We have cosine squared plus sine squared, which is 1. So we get this. So this is our cross product in this numerator here. So let me copy this. So negative 3 root 7, 0, 49. So go back to whatever color I had here before. Come on now. It's beautiful royal purple here. So we had magnitude of negative, I think it was 3 root 7, I say 7, I write 3, 7, 0, and 49 over magnitude of that mess. Okay, so that's how we did the cross product, whatever. Let me go to red again so we know this is separate. All right, so now I'm going to figure out what the magnitude of the denominator is rather than copy that down. So we're going to get negative 7, oh wait, I lied. So square root of negative 7 sine of t, we're going to square that. So that makes 49 sine squared t plus 7 cosine squared of t. I'm just squaring every term and adding them. Pythagorean Theorem. And then plus 9 sine squared of t, all square rooted. What does this make? So I can see that we have 58 sine squared. So we have 58 sine squared of t plus 7 cosine squared of t. Actually, maybe that's not a good way to do this. Let's go, I can see what we can get 1 here. So I'm going to break 2 of these off. I'm going to make this 7 cosine squared plus 7 sine squared plus 2 sine squared. And I'm going to bring 2 of those over to the 49. So that's 51 sine squared of t plus 7 cosine squared of t plus 7 sine squared of t. I don't even know if this is going to help. We'll see. And so now this is just 7. So this is a square root of 51 sine squared of t plus 7. Does that help me? No, I don't really think so. Let's make sure I didn't make a mistake. I really doubt that I took the derivative wrong, but let me check that. So that would be, first derivative would be negative 7 sine, yep. Root 7 cosine, yep. Negative 3 sine. Okay, good. And then square, square, square. All good. All right, well. Rather than do that yet, I'm going to see if it's fine to just, I'm going to just add these for now, because something might shake out whenever I cube it, or something might cancel, who knows. So I'm going to make this 58 sine squared t plus, I was just hoping that it would be perfect square so that it would make this a lot easier. Cosine squared of t. Okay, so that's the magnitude of that, and so I got to cube that. It's gonna be nasty. So we're gonna go change the color back. Okay, so this is gonna be cube root 58 sine squared of t plus 7 cosine squared. Oh, I'm writing huge because I have this zoomed out. 58 and 7. 58 sine squared. Okay. So this is 58 sine squared of t plus 7 cosine squared of t. That's square rooted. And it's raised to, so I'll just raise this all to the 3/2. All right, good. Now I gotta do this. Okay. Ooh. This is fun. Okay, so magnitude of that vector is going to be, let me change the color again just so we know what's up. I'm doing the magnitude of the top here. So this is going to be 9 times 7 plus 0 plus 49 squared is what? This is going to be 1600 plus 720 plus 81, so that's 2320 plus 81, that's 2401. And we gotta take the square root of that. Is that a perfect square? That would be too easy. It's not divisible by 3, 2401. Oh, of course it's a perfect, man, I'm losing my mind. Of course it's a perfect square. Why did I do that? Oh, okay. This is 2401. All right. So basically, let me recap what's going on here. So this squared is this, 0 squared is 0, that squared is that. I lost the forest for the trees on that. Okay, and then I have to square root all this. So that's 63, so 2464, which there's no way that's a perfect square. There's no way. 2464 is 5. No. Whatever, I'm just gonna leave it like that. Okay. So we got, why is this? Oh. This is root 2464 over this mess, 58 sine squared t plus 7 cosine squared t, all raised to the 3/2. All right, what are we trying to do now with this? So that's the thing, but yeah, there we go. I think that's the answer. It's terrible. I don't like it, but it is what it is. Okay, hopefully you watch this and it's correct, and you plug it in and you get a correct answer and all the points that you could possibly get from this question, and then you come back and say, yeah, Ryan, you got it right. That would make me feel very happy to know. Since it's been so long since I've done any Calc 3. I really would like to tutor more Calc 3 just so I can stay up on it, but nobody really, oh no, that's my post. Nobody, like, people don't really make it that far in math and then think like, oh man, I could really use a tutor. Like, they've been going along the whole time just fine, so they get to Calc 3 and they're like, yeah, I don't need help. And, you know, really, you can do it on your own. It's just, like, having a tutor is such a luxury, you know? Okay, so let me hit refresh here. No new problems. Let's go to math homework. Or homework help or whatever. Homework help. Year 12 math, practicing sigma notation, and how would the solution look? Okay, oh man. Oh, those are hot. Okay. See, with Reddit, if I forget to sort by new, it looks like there's no problems. Let's see if they fixed the by subject for mathematics. Yeah, I really don't know why, but the filter by subject thing on the homework help subreddit doesn't work anymore. Okay, biology, electronics, structural analysis. Let me see this. Okay, somebody answered that 2 hours ago. Yeah, I think there might not be any more questions. Calculus. This looks like a crazy question. The math textbook is talking about separating an integral into two integrals over two complex planes. Screenshot attached. But I'm not sure I understand how I would apply this to the given integral. If anyone can explain how I would go about doing this, it would be really helpful. Fubini's theorem is somebody answered the question, but since such integrals diverge, in this case an inner product on polynomial functions on C2 can be defined by a vector valued function Oh yeah, we did something with this in Fourier transforms. I don't know how to do that though. Financial accounting, circuits, electronics, university, automata, and complexity course. Generating regular expression that contains at most one non-overlapping occurrence of a subword. Huh, that's interesting. Is there a solution? I've been trying to solve this for about 3 days now to no avail. Any help? So let sigma equal set. So is it a function? Okay, whatever. Write a regular expression that generates precisely those words over sigma that contain at most one non-overlapping occurrences of contiguous subword BAA. Oh, that's so interesting. I tried drawing the NFA that corresponds to the language that generates words that only contain at most one non-overlapping occurrence of the subword BAA. However, oh, I see. Okay, so this is the set AB. I don't know the definition of language well enough to work on this. This is like computer science. This isn't even... Well, maybe. I guess you could call it math. I don't know. I wonder what program they're in. Okay, so I tried drawing the NFA that corresponds to the language that generates words that only contain at most one non-overlapping occurrence of the subword BAA. However, when trying to convert the NFA to a regular expression, I realized that I am not really sure what to do when there are trap or dead states in an NFA. When you are trying to write a regular expression from it, for example, the NFA I drew has a trap state where it remains forever if it encounters two occurrences of the subword BAA. This causes a problem when I'm trying to convert it into regular expression since there are no outgoing arrows from that state. I tried ignoring the trap state and wrote the regex by only considering the rest of the NFA, but the answer turned out to be wrong. That's very cool. Yeah, I don't think I can help with that. Find the perimeter and area of the kite and the kite below. Alright, here's a math problem that's not done, but it's kind of old. How long ago? It was 12 hours ago. The kite below. FH equals 12, EK equals 8, EG equals 20. I guess I'll try this. All right. So since this is a kite, this is equal to this. This is equal to this. This is a right angle. We're told that FH equals 12, and the diagonal here bisect each other. So if FH is 12, which is from there to there, then this is 6 and this is 6. Or no, I'm sorry. The long diagonal bisects the short diagonal. And I think this is enough to figure it all out. Moreover, one of the two is perpendicular. Yeah. Also the angle. Okay. So 6 and 6. EG is 20. So like, whoa, goodness. EG is 20. That's 20. But we're also told that EK is 8. So 20 minus 8 is 12. That should be enough to figure out everything. We're just going to have to do a bunch of Pythagorean theorem. So to figure out, let's call this X and call this Y, because we need those for the perimeter. Thank you. And so this would also be X, this would also be Y. So 8 squared plus 6 squared equals X squared. That's the Pythagorean theorem. And so this is 64 plus 36 equals X squared. And then so X squared equals 100. Right, 90, yeah. And so X equals 10. We'll just take the square root of both sides to get that. So this is 10, this is 10. Then we can do the same thing for Y. So 6 squared plus 12 squared equals Y squared. So Y squared equals 36 plus 144, which gives us Y squared equals, this is 170, 180, right? Yeah. All right. And so that's going to be Y equals 3 root 10. No. This is like 6 times 3 times 10. Which is, oh, it's 90 times 20, so that's, it's going to be 12 root 5. I'm out of control. This is 9 times 2 times 10, which is not 3 squared times 4 squared times 5. Okay. So, yeah, 12 root 5. Okay. No, I knew something wasn't right. This is 9 times 20, which is 3 squared times 2 squared times 5. There we go. So 6 root 5. Boom, 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 boom. Okay, so this is 6 root 5. This is 6 root 5. And then, so we do, the perimeter is 10 plus 10 plus 6 root 5 plus 6 root 5, which is 20 plus 12 root 5. And, yeah, that's the perimeter. Then, so this is the perimeter. Then the area, we could just, you know, because there's a symmetry, this side is the same as this side. We know the height of this triangle on the top is 6. The base is 20. So we can do 1/2 base times height for the top triangle is 1/2 6 times 20, which is 60, and we have to double that because these are the same area. So the area is 120. Okay, cool. And you know, you can put this into your calculator. I don't know what that value is. Oh, did I even tell him? Yeah, I did. Okay. Concurrent viewer. Let me see. Refresh. I guess nobody does homework on Saturday. Probably Sunday is the way to get it done. Physics grade 12. How would I get the formula on the right to solve this? Is it a common triangle formula? Physics poetry. Can't help you with that. Okay. Somebody answered. This picture was taken from the answer key, and I have no idea how they got the formula. Okay, so that's the original poster. Mountaineer remains in equilibrium while climbing a vertical cliff. The tension force on the supporting rope is 75. How would I get the formula on the right to solve this? Oh, yeah. That formula is the law of cusps, right? What is F? F. S squared plus force of gravity squared plus tension squared minus 2. Yeah. Good question. Anything else? I feel like I answered this one. Maybe this is a repost. Let me check, see if that's a repost. Oh yeah, they posted it in both. Alright, let me just let them know. Yeah. All right, bummer. I think that's all of them. Let me try one more time. Go back to cheat at math. New. Well, yeah, I think that's all for today. Oh, somebody liked it. Yeah, thank you. That's awesome. I love that. I don't get a whole lot of like interaction with the videos usually, so it's cool whenever that does happen. Yeah, I don't really want to quit yet because it's, I mean, I'm only an hour into this, but I don't know. There's like nothing else out there right now to do. I probably should change the thumbnails on my videos. I don't know. What can I do? Well, I guess that's it for today, probably. All right. Yeah. If anybody has any questions, just, you know, send them to me. I definitely want to do some questions, post some comments. If there's any kind of content you want me to create, let me know. If you got a homework assignment and you want me to just do it for you, I'll put it up, do a stream of it, and, you know, you can invite your classmates or whatever, and we can all answer questions together and kind of like get to the bottom of things. Yeah. All right. Have a good weekend, everybody.